The flame arced through the morning haze like a liquid sun, a roaring jet of ignited fuel that bent the air itself. It was 06 for 7 hours, February 23, 1945, on the black volcanic slopes of Iwo Jima's southern beaches, and Corporal James Hartley, of the 4th Marine Division's 1st Battalion, 23rd Marines, squeezed the trigger of his M22 to Flamethrower for the third time that morning. The stream shot forward 35 yards, reached the narrow concrete slit of the Japanese pillbox, and vanished inside. For 2 seconds, nothing. Then came the scream, high, inhuman, cut short by the explosive whoosh as superheated air consumed everything organic in the bunker. Hartley didn't look. He turned left, waved his rifle squad forward through the sulfuric smoke, and moved toward the next fortification. Behind him, the pillbox vented black smoke and the sickly sweet stench of burnt flesh and gasoline thick. Inside, the 4 defenders who had survived 3 days of naval bombardment were gone in less time than it took to exhale. Us Marine Corps After-Action Report. V. Amphibious Corps, March 1945, 200 yards to the north. Inside a reinforced bunker buried 15 feet beneath volcanic rock and concrete, Lieutenant Tadamichi Kurabayashi Jr., nephew of the island's commanding general, heard the screams over the field telephone. His hand shook as he scribbled into the log. Positions 14 through 17, no response. Flame weapons. Men cannot escape. Morale. He didn't finish the sentence. The phone line went dead. Outside, the Marines were advancing again, and every defensive strongpoint Kurabayashi had spent months engineering was being cracked open. One burning jet at a time. Under search of equivalent. Japanese 109th Division Records. Post-war translation, 1946. Across the Pacific Theater in early 1945, a grim pattern had emerged that Japanese commanders could not explain and their soldiers could not survive. From the caves of Peleliu to the coral ridges of Okinawa, from the jungles of Luzon to the fortified hills of Iwo Jima, American assault teams were systematically neutralizing defensive positions that should have been impregnable. Bunkers designed to withstand 500-pound bombs, reinforced with steel rails and 2 feet of concrete, pillboxes sited for interlocking fields of fire. Spider-hole networks invisible until triggered. None of it mattered. The Americans would arrive, with their rifle squads, pin the position with suppressive fire, and then a lone figure in bulky tanks and hose would step forward. 30 seconds later, the position was silent. Survivors who emerged were burned beyond recognition or suffocated by the sudden vacuum of oxygen. Those who stayed inside died faster. U.S. Army Combat Studies Institute. Flamethrower tactics in the Pacific, 1947. The flamethrower was not new. The Germans had used crude versions in World War I, the Italians in Ethiopia, and the Japanese themselves had deployed Type 93 and Type 100 flame projectors in China and Malaya with sporadic success. But something about the American models, the M1, M1A1, and especially the M22 was different. Japanese intelligence officers, reviewing captured manuals and interrogating prisoners, noted with alarm that U.S. flamethrower teams operated with ruthless efficiency, seemingly unlimited fuel supply, and a mechanical reliability that their own flame units could never achieve. More disturbing was the psychological dimension. Japanese soldiers, trained to endure artillery, machine gun, fire, even starvation, began showing signs of panic and premature surrender when flamethrower teams appeared. In post-war interrogations, former IJA officers used words like demonic, unnatural, and the weapon that breaks men's minds. USSB's Interrogation Report, 489, November 1945. By February 1945, the strategic situation in the Pacific had calcified into a brutal mathematics. The Japanese Empire, stripped of its navy at Leyte Gulf and its air power over the Marianas, had adopted a defensive doctrine of attrition. Fortify every island, dig deep, make the Americans pay in blood for every yard. On Iwo Jima alone, General Tadamichi Kurabayashi had overseen the construction of 11 miles of underground tunnels, 1,500 fortified positions, and a defensive network designed to inflict 20,000 American casualties and delay the invasion for 2 months. His 21,000 defenders had orders to kill 10 Americans each before dying. There would be no bonsai charges, no wasted lives, only grinding. Invisible Defense, Iwo Jima, Legacy of Valor, Combat Historians, compilation, 1985. The Americans knew what awaited them. Intelligence estimates predicted 30 days of fighting and 15,000 casualties for V Amphibious Corps, 70,000 Marines and attached army units. Admirals and generals had studied Tarawa's seawall carnage, Saipin's cave holdouts, and Pelalua's ridges, each battle a laboratory of costly lessons. The answer, they believed, lay in firepower. 6,800 tons of naval shells in 3 days, napalm strikes, tank infantry coordination, and, critically, specialized assault weapons. Among these, the portable flamethrower had evolved from a niche terror weapon into a doctrinal cornerstone, a tool as essential to the Pacific infantrymen as the M1 Garand or the .30 caliber machine gun. Marine Corps Gazette, Lessons from the Central Pacific, May 1945. But doctrine and production statistics told only half the story. The other half was written in flame and screams, in the particular horror that made veteran soldiers, men who had walked through machine gun fire without flinching, refuse to enter a bunker after a flamethrower team had cleared it. It was a weapon that didn't just kill, it erased. It turned fortifications into crematoriums and men into ash. And in the brutal algebra of the Pacific War's final year, where every Japanese position had to be taken and every defender was prepared to die in place, the flamethrower became the key that unlocked an empire's last redoubts. Corporal Hartley reached the next pillbox and signaled for his assistant to swap fuel tanks. The M222 carried 4 gallons of thickened gasoline napalm before that term became infamous, which gave him approximately 10 one-second bursts. He'd used 7. The fresh tanks felt heavy on his back. 68 pounds of potential Hellfire Technical Manual TM3-2380. Chemical Warfare Service, 1944. Ahead, the volcanic ridges of Iwo Jima climbed toward Mount Suribachi, and each ridge concealed another 100 firing positions. Hartley didn't think about the men inside, or what the flame did to them. He thought about his rifle squad, about getting them through the day alive. He raised his igniter, checked the wind direction, and moved forward into the smoke. Behind him, the island was burning. Ahead, an empire's final soldiers waited in the dark, knowing what was coming, unable to stop it, beginning to understand that no fortification, no courage, and no doctrine could withstand the weapon that had learned to weaponize fire itself. The secret was not the flame. Fire had been a weapon since humanity's first wars, and every industrial nation by 1945 had experimented with projecting it mechanically. The secret was the fuel, or, more precisely, what American chemists had done to gasoline to transform it from a liquid that splashed and dissipated into a substance that clung, penetrated, and burned with the intensity of a blast furnace. In a nondescript laboratory at the Massachusetts Institute of Technology in early 1942, a team led by chemist Louis Fisa had been tasked with solving a problem that seemed trivial compared to atomic physics or radar: how to make gasoline stick. Their answer, designated isobutyl thickener and later refined into napalm, a portmanteau of naphthenic and palmitic acids turned common petroleum into a gel that burned at 1,500 to 2,200 degrees Fahrenheit, adhered to any surface, including wet concrete and human skin, and could not be extinguished with water. Office of Scientific Research and Development. Summary. Technical Report. Division 11, Volume 3, 1946. This gel, produced in converted soap factories from Toledo to Los Angeles at a rate exceeding 180,000 pounds per day by 1944, was the invisible technological edge that made American flamethrowers incomparably deadlier than their Axis counterparts. Chemical Warfare Service Production Report, December 1944. Japanese flame weapons, by contrast, used raw gasoline or light oil. The Type 93 and Type 100 models achieved ranges of 15 to 20 meters under ideal conditions, but the fuel dispersed rapidly, often failed to ignite, and produced flames that could be avoided or suppressed. Captured Japanese technical manuals revealed desperate attempts to replicate Allied fuel thickening through crude mixtures of rubber solution and latex, but supply shortages and chemical expertise gaps meant these experiments never reached field units in meaningful quantities. USSBs, Japanese Ordnance, Equipment and Supplies, 1946. A Japanese defensive manual captured on Okinawa contained a chilling marginalia note. Later translated, American flame reaches into the tunnel, turns, our flame stops at the entrance. There is no defense except to die before it arrives. U.S. 10th Army Translation Section. Document J4478, April 1945. The psychological gap between possessing a weapon and facing a superior version of it cannot be overstated. Japanese soldiers understood fire, but the napalm thickened jets that pursued them through tunnel networks and filled bunkers with liquid fire that burned for 7 to 10 seconds, long enough to consume all oxygen in an enclosed space, represented something beyond their doctrinal comprehension. M222 Flamethrower itself, manufactured primarily by the E.B. and A.C. Whiting Company in Massachusetts and the Chemical Warfare Services Arsenal in Edgewood, Maryland, was a masterpiece of brutal engineering. The complete system weighed 68 pounds fully loaded, 2 cylindrical fuel tanks containing 4 gallons of napalm gel, a smaller pressure tank filled with nitrogen gas at 300 to 375 psi, an ignition system using either electric battery or hydrogen torch, and the wand assembly with trigger valve and nozzle. The weapon's effective range, contrary to Japanese estimates of 20 meters based on their own equipment, reached between 20 and 40 meters depending on wind conditions, with the napalm gel maintaining coherence across the entire distance. Technical Manual TM3 to 378, Portable Flamethrower M222, September 1943. The production infrastructure behind this weapon revealed American industrial capacity at its terrifying peak. By June 1945, monthly production exceeded 3,500 complete units, with logistics chains delivering replacement fuel cartridges, pressure tanks, and spare igniters to forward supply dumps on islands that hadn't existed on maps 2 months earlier. Army Service Forces Industrial Production Report, June 1945. Engineers at the Edgewood Arsenal had even developed winterized seals and tropical-rated hoses after early models failed in New Guinea's humidity, a level of iterative refinement that Japanese ordnance bureaus, starved of materials and time, could no longer match. The weapon's tactical employment evolved, through blood lessons, into a ruthlessly efficient system. Marine Corps doctrine by 1945 designated flamethrower operators as specialists within rifle squads, typically the strongest Marines due to the weapon's weight, but also men with specific psychological profiles, those capable of performing the weapon's grim work without hesitation. The standard assault procedure, codified after Tarawa and refined through Louis, followed an invariable sequence. Infantry established a base of fire to suppress the target bunker. Browning automatic rifle gunners and .30 caliber machine guns prevented any Japanese soldier from engaging the flamethrower operator during his approach. The operator advanced to within 30 meters. One Marine armed with rifle or submachine gun accompanied him as security. The operator fired a 2 to 3 second burst directly into the firing slit or ventilation shaft. The assault squad immediately advanced while defenders were incapacitated, using demolition charges or grenades to collapse the position permanently. Fleet Marine Force, Pacific Training Memorandum 6244, November 1944. This ballet of violence, repeated hundreds of times daily during major assaults, transformed flamethrower teams into the most valuable and most targeted personnel on the battlefield. Japanese snipers learned to identify operators by their distinctive silhouette and prioritized them above officers, with the grim result that flamethrower Marines suffered casualty rates approaching 92% in prolonged campaigns. Marine Corps Historical Division, Casualties by Moses Pacific Theater, 1941 to 1945. The Battle of the Blockhouse on Iwo Jima's northern sector, February 27, 1945, exemplified the weapon's decisive impact. A reinforced Japanese strongpoint designated Hill 382, nicknamed the Amphitheater by Marines, anchored Kuribayashi's second defensive line. The position comprised a 3-story concrete communications bunker surrounded by 47 interlocking pillboxes, all connected by tunnels and protected by minefields. For 36 hours, elements of the 3rd Marine Division's 21st Regiment assaulted the position, losing 196 men killed and 560 wounded, while gaining less than 100 yards. Artillery was ineffective against the buried fortifications. Tank guns couldn't elevate sufficiently. Satchel charges were intercepted by defensive fire before reaching targets. 3rd Marine Division Special Action Report, March 1945. On February 27, at 14:20 hours, Captain James Headley assembled 8 flamethrower teams from companies E, F, and G, supported by 4 M4 Sherman tanks mounting 75mm guns and 2 M4A3R, 3 Zippo tanks equipped with mechanized flamethrowers derived from the Navy's Mark I system. The assault commenced with the Zippo tanks advancing to within 50 meters and saturating the hillside with streams of napalm, reaching 90 meters in length, each burst consuming 80 gallons of thickened fuel. Marine Corps Tankers Association, Flame Tanks, in the Pacific, 1986. Under this cover, the portable flamethrower teams moved bunker to bunker, pouring fire into each aperture for sustained bursts that exceeded doctrinal recommendations. Some operators emptied entire 4-gallon loads into single positions. By 1710 hours, Hill 382's main defenses had collapsed. The position that had cost nearly 800 casualties over 2 days fell in under 3 hours. Once flamethrowers were concentrated, the casualty exchange rate was grotesque. 8 Marines killed, 43 wounded, and an estimated 530 Japanese dead, most found in bunkers with no visible wounds except for carbon monoxide asphyxiation and flash burns. V. Amphibious Corps Intelligence Report, 17-45, March 1945. The aftermath revealed why the weapon terrified defenders beyond rational fear. Engineers entering the amphitheater complex found bodies fused to concrete, steel rifle barrels melted, ammunition that had cooked off from ambient heat rather than direct flame, and, in the deepest tunnels, men who had died from oxygen deprivation without a single burn. The napalm had consumed all breathable air in interconnected chambers, extending 40 feet from the flame's point of entry. The discovery forced a recalculation of Japanese defensive doctrine. Tunnels, previously considered the ultimate protection, became death traps when flamethrowers reached their entrances. A captured Japanese engineering manual dated March 3, 1945, 1 week after Hill 382, showed desperate revisions, increased tunnel ceiling doors, water-filled blast chambers, even instructions to flood tunnel sections deliberately, all attempting to counter a weapon for which no effective defense existed. Captured Enemy Documents section, document 4521, AG, April 1945. The flamethrower had become more than a weapon. It was a doctrinal solvent, dissolving defensive advantages that had cost the Japanese Empire months of labor and irreplaceable engineering expertise. And as spring 1945 arrived and the invasion of Okinawa loomed, American logistics officers were already shipping the next evolution: truck-mounted units, amphibious flame vehicles, and experimental man-portable models with doubled fuel capacity, preparing for the fortified home islands where every cave, every building, every tunnel would need to be cleared, and where the flame that terrified Iwo Jima's defenders would burn on an unimaginable scale. The strategic impact of American flamethrower superiority extended far beyond tactical victories on volcanic islands and coral atolls. By April 1945, as the invasion of Okinawa entered its blood-soaked second month, Japanese defensive doctrine had fractured under the psychological weight of a weapon that turned their greatest tactical advantages into liabilities. General Matsuru Oshijima, commanding the 32nd Army's 77,000 defenders, had constructed a defensive masterpiece across Okinawa's southern ridges, the Shuri Line, a network of caves, reverse slope positions, and mutually supporting strongpoints that should have bled the American 10th Army for months. Instead, the line collapsed in sections wherever flamethrower-equipped Marine and Army assault teams concentrated their efforts. On May 11, 1945, elements of the 1st Marine Division's 5th Regiment neutralized the Wanadrua fortifications, a complex that had repulsed attacks for 17 days in a single morning using coordinated flamethrower and demolition assaults that consumed an estimated 12,000 gallons of napalm gel. 10th Army Action Report, Ryuka's Campaign, Chapter 7, 1945. The kill ratio in these flamethrower lead assaults averaged 23-1 in favor of American forces, compared to 4-1 in conventional infantry attacks against similar fortifications, a statistical divergence that transformed operational planning across the entire Pacific Theater Operations Research Office, Johns Hopkins University, Comparative Lethality Study, Pacific Operations 1944-1945, 1950. The psychological dimension proved equally decisive. Post-war interrogations of Japanese prisoners revealed a phenomenon that intelligence officers initially struggled to classify: anticipatory demoralization. Soldiers who had never faced flamethrowers directly, who knew of them only through rumors and survivor accounts, began exhibiting combat ineffectiveness and elevated surrender rates when American assaults commenced, before flamethrowers were even employed. A captured diary from a corporal in the 24th Division on Okinawa, dated May 19, 1945, recorded, "We hear the Marines bring the flame weapons today. My hands shake writing this. I have decided if they come to my position, I will shoot myself rather than wait for the fire. This is not cowardice. I have seen what the fire does. It is not a soldier's death." 10th Army Translation and Interrogation Center. Document 2847A, June 1945. American psychological warfare units, recognizing the weapon's disproportionate mental impact, began incorporating flamethrower imagery into leaflets and loudspeaker broadcasts, not as crude threats but as factual descriptions of what awaited defenders who chose to fight in fortified positions. Surrender rates in sectors where these psychological operations preceded assaults increased by 340% compared to sectors receiving only conventional bombardment warnings. Office of War Information. Pacific Theater Psychological Warfare Report, July 1945. The industrial and logistical machinery sustaining this advantage revealed American material supremacy at its most overwhelming. By summer 1945, the Chemical Warfare Service Logistics Network was delivering 47,000 gallons of napalm gel daily to forward areas across the Pacific, produced by 32 converted manufacturing facilities stretching from Pennsylvania to California. The Standard Oil Development Company's Bayway refinery in New Jersey alone processed sufficient naphthenic acid to produce fuel for 8,000 flamethrower operations monthly, while the Sharples Solvents Corporation in Philadelphia synthesized palmitic acid derivatives at rates that exceeded the total chemical warfare production capacity of Japan, Germany, and Italy combined war production board. Chemical Division Production Summary, June 1945. The engineers and chemists enabling this production, men like Dr. E.B. Hirschberg at Harvard, who refined napalm ignition consistency, and the all-female workforce at the Granite City Army Depot in Illinois, who assembled fuel cartridges at a rate of 1,200 units per 8-hour shift, received no medals and appeared in no newsreels. Yet their contributions proved as strategically significant as any carrier task force. Army Service Forces, Civilian Employee Recognition Records, 1945. The maintenance infrastructure was equally sophisticated. Forward repair depots on Guam and Saipan could completely rebuild M222 units in under 4 hours, replacing corroded hoses, recalibrating pressure systems, and testing ignition reliability with standardized protocols that kept operational readiness rates above 91% even in tropical conditions that rusted rifles and jammed machine guns within days. 5th Amphibious Corps Ordnance Report, May 1945. The human cost of wielding this terrible advantage was borne disproportionately by the flamethrower operators themselves. Staff Sergeant Robert Wilson of the 4th Marine Division, who operated his M222 through Saipan, Tinian, and Iwo Jima, described the psychological burden in a 1946 interview. "You don't forget what burning a man alive sounds like. You don't forget the smell. I did my job because it saved my squad, because every bunker I burned was 10 Marines who didn't get killed rushing it. But I dream about it still. I'll dream about it until I die." Marine Corps Historical Division, Oral History Collection, Interview 447B, November 1946. The specialized psychiatrists attached to V Amphibious Corps by early 1945 noted elevated rates of what would later be termed post-traumatic stress among flamethrower veterans. A recognition that even necessary violence extracted psychological costs that no amount of tactical success could erase. Navy Medical Department, Combat Psychiatry Observations, Central Pacific, 1946. Yet these same men volunteered for flamethrower duty at rates that mystified re-echelon personnel, driven by a grim pragmatism: better to carry the flame and live than to assault bunkers with rifles and grenades and die. As the war entered its final months, planning for Operation Downfall, the invasion of Japan's home islands incorporated flamethrower doctrine at scales that dwarfed previous operations. Staff projections called for 75,000 portable flamethrowers to be deployed during the first 30 days of the Kyushu landings, supported by 300 mechanized flame tanks and specially modified landing vehicles capable of projecting napalm across beach obstacles. Joint Chiefs of Staff, Operation Downfall Planning Documents, Annex 17, June 1945. Chemical Warfare Service production schedules allocated 21 million gallons of napalm gel for the invasion, enough to outfit every rifle squad in the Pacific with sustained flamethrower capability for 60 days of continuous operations. The Japanese, aware through intelligence intercepts and simple observation of American doctrine, evolution, prepared defenses explicitly designed to counter flame weapons, flooding systems in coastal tunnels, heat-resistant blast doors in command bunkers, even suicide squads trained to rush flamethrower operators before they could deploy their weapons. Japanese Homeland Defense Preparations, USSB's Report 72, December 1945. The prospect of flamethrower warfare extending across the Japanese archipelago into cities where every building became a potential strongpoint and every subway tunnel a death trap represented an escalation of brutality that both sides understood would dwarf even Okinawa's horrors. The atomic bombings of Hiroshima and Nagasaki, followed by Japan's surrender on August 15, 1945, rendered Operation Downfall unnecessary and left the flamethrower's ultimate strategic test unperformed. Yet the weapon's legacy shaped post-war military doctrine in profound ways. Marine Corps training doctrine enshrined flamethrower teams as permanent elements of infantry organization, a structure maintained through Korea, Vietnam, and into the 1970s. When portable flamethrowers were finally retired in favor of thermal rockets and incendiary grenades that delivered similar effects without requiring operators to close within 30 meters of targets. Marine Corps Warfighting, Publication 3-35.3, Military Operations on Urbanized Terrain, 1998 edition, Historical Appendix. The Korean War saw M22 flamethrowers employed extensively in bunker assaults during the static defensive period of 1951 to 1953, with North Korean and Chinese defenders exhibiting the same psychological vulnerability that Japanese forces had shown, often abandoning positions at the first sight of flame teams rather than waiting to engage. U.S. Army Combat Studies Institute, Flame Weapons in Korea, 1952. The weapon's true descendant, however, was not another flamethrower but the entire family of thermobaric weapons, systems fuel air explosives, bunker-busting thermobarics, even the controversial MOAB bommel of which applied the fundamental insight American chemists had developed in 1942, that controlling how fuel burns is as important as what fuel burns. The ethical questions surrounding flamethrower employment, debated intermittently during the war itself, intensified in post-war years as photographic evidence and veteran testimonies made the weapon's effects undeniable. International humanitarian law discussions in the 1960s and 1970s grappled with whether incendiary weapons constituted unnecessary suffering, culminating in Protocol 3 of the 1980 Convention on Certain Conventional Weapons, which restricted but did not ban their use. United Nations Treaty Collection, Convention on Certain Conventional Weapons, Protocol 3, 1980. The United States ratified the protocol with reservations, maintaining that incendiary weapons remained legitimate against military targets, a position rooted in the Pacific War experience where flamethrowers had demonstrably saved American lives by reducing the casualties required to neutralize fortified positions. The moral calculus, whether the